In this aptly named podcast, we are going to go over how to both detect and measure radioactivity. All right, one thing that makes radioactivity a little bit challenging for us humans is that you cannot smell radioactive particles. You can't see them, you can't taste them, you can't hear them, you can't feel them. So you may be in the presence of something that's very radioactive and have no idea. Keep in mind, we are exposed to small amounts of radiation daily. These come from cosmic rays, your soil, TVs, dental x-rays. There's a ton of sources that we have, just this background cosmic radiation. We can detect dangerous levels of radiation. It's actually important to do so since we can't sense that we're in the presence of dangerous radiation. And so we have tools to measure radiation, and these include the Geiger counter, which I'm sure you've heard of, film, as well as radiation badges. And what you're seeing on the upper right-hand side is a Geiger counter. And a Geiger counter has an argon gas-filled tube or canister. And when it's in the presence of something that's radioactive, this is not showing up very well, but there's a little radioactive piece of metal. The gas that's inside becomes ionized, or it becomes charged. And so depending on what type of Geiger counter you have, you're going to see a dial change to kind of show you how radioactive this substance is. Some of the Geiger counters also make kind of a staticky sound that gets louder, and you hear the staticky click that becomes more frequent depending on the intensity of the radiation that's being detected. If you work in a medical setting where maybe a radiotherapy lab, you're probably going to wear a badge on your body, and this will change when you're in the presence of higher levels or dangerous levels of radiation. And this is just a good way to make sure that you aren't coming in contact with high levels or dangerous levels of radiation on a regular basis. Nuclear radiation has very high energy, and because it can penetrate the surface of an object or an organism, it can cause pretty severe damage. The cells that are more susceptible to nuclear radiation are those that undergo rapid cell division. So think about bone marrow, reproductive organs, skin, your intestinal tract. These are going to be the most sensitive to radiation. So we use a ton of different units to measure radiation depending on what we're specifically looking at. So for example, if we are looking at the intensity of our radiation, we're going to use the SI unit of becquerels, BQ, or Curie's, CI. And this is really telling us what the intensity of the radiation is emitted by a source. We also use specifically Curie's to administer drugs and for diagnostic tests. And you're going to see this unit used the most. Keep in mind that all of these can be used as metric conversions. So I could have Curie's. So 1 Curie would be equal to 1,000 millicuries. Okay, so we can do metric conversions there. If we want to measure the absorbed dose, we'll use grays or rads. This will tell us how much radiation energy is absorbed by something that the radiation hit. So how much radiation is being absorbed by water or the human body. And finally, the effective dose, we use sieverts and REMS. And this is the absorbed dose, so what we used before, multiplied by scaling factors that correct for differences in the ease with which a particular type of radiation damages a particular type of human tissue. Again, we're going to play mostly in Curie's.